Hi everybody and welcome. In today's video we are going to be dealing with solving for unknowns and triangles again. And I know that it sounds like something that we've done before, but in this case it's actually going to be when we have triangles that don't have right angles. So a bit of a new relationship here. Things like Pythagorean theorem, the trigonometry that we've done so far only work if we have right triangles. So what can we do? What can we use? The first thing that's going to come up a lot is the law of sines. And this is a relationship that applies to the angles and sides of all triangles. So this can either help us solve for a side or solve for an angle, just like before, but now we don't need to have it as a right triangle. It doesn't have to be 90 degrees. So this specifically helps us in the situations where we have two angles and one side, or if we have two sides and one opposite angle. So an angle that is directly opposite from one of the sides that we have given. So a few things notation-wise that are really, really important to make sure that we have down 100%. The labeling, just like before, is beyond important. So let's start off with a triangle. So here is a triangle that is not a right triangle. There's no 90-degree angle here. And we'll call it triangle ABC. So one thing to take note of, angles are capitalized. Our sides are lowercase. And how do we find them? We go directly across from our angles. So side C is directly across from angle C. Side A is directly across from angle A, and side B, you guessed it, directly across from angle B. In this case, our sides are lowercase. So B is across from B, A is across from A, C is across from C. So in this situation, we actually don't care anymore about opposite, hypotenuse, and adjacent. We're just looking for lowercase and uppercase A, lowercase and uppercase B, and lowercase and uppercase C. If we have those three things, we know enough to solve. So what is the law of sines? It's an equation. The sine of A divided by lowercase a is equal to the sine of B divided by lowercase b is equal to the sine of C divided by lowercase c. So here, we actually only need two of these at any given time. And let's say, for instance, you have A and you have B, you would use this. That would be your equation. But what if you had A and you had C? Well, then you would use those two and set them equal to each other. There's three terms here, but all that we care about is setting them equal to each other. So basically, whatever piece of this puzzle you have, set it equal to another piece of the puzzle. Doesn't have to be in order, just as long as A is over A, B is over B, and C is over C. If we have those things and they hold true, we are happy and we're able to solve. So let's take a look at a triangle where we don't have a 90-degree angle and see if we can apply the law of sines. So in this situation, they are asking us to solve for x. We don't have a 90-degree angle. We can't use trigonometry. So basically, we have to go through and take what we have and solve. So the first thing that you should do, just like we did before, is label. If this is angle C, this is side C. If this is angle B, this is side B. Remember, directly across from each angle is its corresponding side. So here we have B and C, which means that we are going to use those pieces of our puzzle. Sine of B over B, sine of C over C. And let's just plug in our terms. So we know that angle B is 45. We know that side B is x, so that's what we're trying to solve for. We know that angle C is 80. And we know that side C is 3. So now it's time to solve. So how do we solve something like this? Well, we have an equal sign and we have two fractions. So actually, just like we were doing solving trigonometry before, that set us up for success here. We can cross multiply. So in this case, we're going to have 3 times the sine of 45 equals x times the sine of 80. And we want to get x alone. So how do we do that? Well, we have x times something. Remember, sine of 80 is a number. So what we can do here is divide by that number. So divide by the sine of 80 and divide by the sine of 80. So here, sine of 80 simplifies to 1. And on the other side, we just punch all of that into the calculator. So 3 times the sine of 45 and divide that by the sine of 80. When we do that, we'll get an answer of x equals 2.15. And that's our missing side length. We did it. So we just actually successfully solved for the missing side length of a triangle that is not a 90-degree triangle. It's not a right triangle. And we did it using the law of sines. So again, to recap here, what we're doing is we're taking pieces that we know and plugging it in and using some trig from the past, but it's basically just calculator math here. We're not using SOHCAHTOA anymore. We're focusing on the law of sines and plugging in individual pieces. So some interesting stuff here. Honestly, can definitely get a little bit tricky in terms of labeling things and basically seeing where everything belongs. But if we have things organized well, we're definitely going to be in very good shape to solve correctly. So with that being said, let's try another example. So a good rule of thumb is just have this as a reference. That way, when we're taking pieces of this, we can see which pieces we are selecting and we can plug them in. We have another triangle here. This is an obtuse triangle. We have a 105-degree angle, and we are given this is side 6, and this is side 9, and they're calling this one XYZ. Well, what in the world? We don't have A, B, and C. What do we do? Well, X, Y, and Z are just naming conventions, so if you want to, you can rename them. If this makes it easier for you, let's say that this is A, this is B, and this is C. And we have to remember what we started with, that way we can give them the answer that they're looking for. But here, again, we're just kind of going through one at a time and seeing if we can solve. So what we are looking to solve for here is the measure of angle X. So that's what the question is asking us. So it would say, what is the measure of angle X? That would be the question. So in this case, we're looking to solve for this corner. So we should keep labeling, make sure we don't forget anything here. So across from this side here is lowercase a, across from this here is lowercase b, and this would be lowercase c. We don't have any information about c though. It looks like we're given information about b, and we're given information about a, so we should use that part of our law of sines. Okay, so we have that information, so now it's time to use it. So let's plug in what we know. So we don't know angle A, so we're going to leave sine of A like that. We do know lowercase a is 6, though. Secondly, sine of B. We do know the measure of angle B, it's 105 degrees. And we do know the length of side lowercase b is equal to 9. So just like before, we can go through and cross multiply. So 9 times the sine of A equals 6 times the sine of 105. We want to get A just by itself here, so what we have to do is basically take anything that's not an A and move it out of there. So 9 times the sine of A, well, we can just divide by 9 and divide by 9 here. We do this, that simplifies, and we're left with the sine of A equals 6 times the sine of 105 degrees, all over 9. And in this case, we don't know A, but we do have a value. So how do we solve? What do we do? Well, this is actually just the same thing that we did before, a little bit more complicated with our numbers here, but we switch positions. So the A and all of that in the parentheses switch, so we'll have sine, or our inverse sine of 6 times the sine of 105 over 9 is equal to A. And that's actually something that we can just pop into the calculator. So we'll do second sine to get inverse sine, and then do 6 times sine 105, close our parentheses there, hit the division sign, hit 9, close our parentheses again. So basically just typing all of this mess into the calculator at once, hitting enter, and we'll get an answer of 40.0, or 40.1, I guess we round it. And that is our measure of angle A. So the challenge to that question is that we had to do inverse sine. So if you're solving for an angle, you're going to need to use that inverse trig function. Not something that we've done before, but just a reminder here. So again, solving for that angle, that's what brought us to this function instead of just the regular sine. But if we have that value, just remember that sine of a number is just a decimal. So like sine of 105, that's something that we know. It's just a number. Punch it into your calculator, and you'll be able to get that answer that you're looking for. So two types of questions that you're going to be asked to answer today. One is solving for sides, one is solving for angles. So the big focus of today's class is to get this law of sines, basically formula written down, and practice. See if you can use it on multiple questions. We have a bunch of practice problems today.